Hello, welcome to this tutorial. It's on Venn diagrams, and in this video we'll be looking at Venn diagrams involving the universal set and three subsets. So let's go. We take our first problem. 1. Given E, that is the universal set, to be set of 1, 2, 3, 4 up to 15. P is set of X such that X is a prime number. Q is set of Y such that 2Y minus 5 greater than 11. R set of 2, 4, 5, 8, 13, 14 and 15. And P, Q and R are subset of E. So that's to say E is the universal set. A. Represent the information on the Venn diagram. B. Show that P prime intersection open bracket Q union Q prime is equal to P prime intersection Q union P prime intersection R prime. We have a C. Find the value of N of P union Q intersection Q prime. Now we start the solution of the problem. We are going to list out completely the sets that are given a set builder form, like P and Q. So we get our P to be set of prime numbers, and here we are going to look at the prime numbers from the universal set, since P is a subset of E. So we go 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, and 13. These are the elements that make up a set P. Now we go to Q. For Q, we need to solve this inequality. That's going to give us 2y minus 5 is greater than 11. Taking this to this side, we have 2y is greater than 16, and dividing both sides by 2, y is greater than 8. So the range of values of y here starting from 9 up till 15. We're going to stop at 15 because Q is a subset of E. So the elements that make up Q are 9, 10, 11, 12, 13, 14, and 15. So, and set R is already given. So we now start the solution from A by representing the information on a Venn diagram. So the rectangle will represent the universal set E, circle will represent P, and the other circle will represent Q, and the third circle will represent set R. So in this case, we are going to start from the universal set, since it is the complete set. So we start with 1. There is no 1 in set P, Q, and R. So 1 is going to be outside the 3 circles. So we have 1. It can be anywhere outside the 3 circles. We go for 2. 2 is in set R and also in set P. So we place it in the region of P intersection Q intersection R prime, which is in this region. So we have 2 there. We go for 3. 3 is in P and it is not in any other set. So 3 will be in this region, that is P only. And we go for 4. 4 is only in R. So R only is this region. So we place 4 there. We go for 5. 5 is in R and also in P. 5 is in R and P, so 5 will be here. 6 is not in R, it is not in P, and it is not in Q. So it's staying outside the 3 circles. And 7 is not in R, it is in P, and it is not in Q. So it is P only. So we have it in the region where we have 3. And 8 is in R, it is not in P, and it is not in Q. So it is R only. So it is in the region where we have 4. And we have 9. 9 is not in R, 9 is not in P, but it is in Q. So it is Q only. This is the region where we have Q only. And 10 is not in R, 10 is not in P, it is in Q only. So we have 10 here. 11 is not in R, it is in both P and Q. So it is P and Q only. The region for P and Q only is this. So we have it there. We go for 12. 12 is not in R, 12 is not in P, it is in Q only. So 12 is in this region. So we have 12 there. 13 is in P, it is in Q, and it is in R. So this is where you have P intersection Q intersection R. So 13 is coming here. 14 is in R, and it is also in Q, but not in P. So 14 will be in this region. And finally 15 is in R, it is not in P, but it is in what? Q and R only. So we have it as here. And we've succeeded in representing these sets on a Venn diagram. So we move to the second part of the problem. We have to show that A prime intersection open bracket B union C prime. So in this case, we need to get A prime and C prime. So to get A prime, it means everything outside the circle of A constitutes A prime. So we now cover set A. Whatever we see outside the circle of A constitutes A prime. So we have 1, 4, 6, 8, 9, 10, 12, 14, and 15. This is A prime. This is A prime. Then we go for C prime. C prime also, it is all those elements outside the circle of C. So we close the C. Whatever we see outside now constitutes the element of C prime. So we have 1, 3, 6, 7, 9, 10, 11, and 12. So this is C prime. So we now look for B union C prime. That is bringing B and C prime together without any repetition of elements. So B union C prime. We have B here, C prime. So there we have 1, 2, 6, 7, 9, 10, 11, 12, then 13, 14, and 15. So we've gotten our B union C prime. So to get our A prime intersection B union C prime, meaning this is A prime and this is B union C prime. So to get that, intersection mean what are those elements that are common to A prime and B union C prime. So we can see we have 1 here, 1 here, 1 is there is 4 here, there's no 4 here, There is 6 here, there is 6 here, so 6 is part. There is 8 here, no 8 here. There is 9 here, there is 9 here, so we pick 9. There is 10 here, there is 10 here, we pick 10. There's 12 here, there is 12 here, we pick 12. There is 14 here, and there is 14 here, we pick 14. There is 15 here, there is 15 here, we pick 15. So the better way of doing this is to concentrate on one set and compare it with the other set. Like I said, I concentrated on A prime, picking 1 is here, 4 is not here, 6 is here, 7, and so on. That's the easier way. Then we have taken care of the left hand side. We look at the right hand side. So since we've gotten A prime and C prime, so what we do now is A prime intersection B. So we go for A prime intersection B, A prime intersection B. So we compare these B and A prime, look at those elements that are common to them. We have 9 here and there is 9 here, so pick 9. There's 10 here, there's 10 here, we pick 10. There's 11 here, there's no 11 here. There's 12 here, there's 12 here, we pick 12. There's 13 here, there's no 13, so we leave 13. There's 14 here, there's 14, we pick 14. There is 15 here, there is 15 here, we pick 15. So we've gotten A prime intersection B. We go for A prime intersection C prime. So A prime intersection C prime, these are the two sets. What are the elements that are common to them? We have 1, 1. 4 here, there's no 4. 6 here, there is 6 here. 8 here, there's no 8 here. 9 here, there is 9 here, we pick 9. 10 is here, there is 10 here, we pick 10. 12 is here, there is 12 here, we pick 12. 14 and 15 are not in C prime. So we have gotten A prime intersection C prime. Now we put two of them together as union. So A prime intersection B union A prime intersection C prime will be bringing together all the elements of the two sets without any repetition. So we have a 1, 6, 9, 10 is here, 10 is here, we pick 10, 12, then 14 and 15. So this is the left hand side, this is the right hand side. We check if they are the same. 1, 1, 6, 6, 9, 9, 10, 10, 12, 12, 14, 14, 15, 15. So we have shown that A prime intersection B union C prime is equal to A prime intersection B union A prime intersection C prime. So we are done with problem B. So we go to C. For C, we have to find the value of n of, that is the number of elements that is contained, the n number of element contained in this set we are going to form. So we need a B prime here. So to get our B prime, again, all these elements outside the circle of B constitute the element of B prime. So we close B. So we now have a 1, 2, 3, 4, 5, 6, 7, and 8. So these are the elements for B prime. So we now look for A union C. We go for the element of A union C. To get A union C, we are bringing A and C together. So we have 2, 3, 4, 5, 7, 8, 11, 13, 14, and 15. So the A union C are 2, 3, 4, 5, 7, 8, 11, 13, 14, and 15. So we now go ahead to say A union B intersecting it with B prime. So A union B intersecting with B prime. So intersecting B prime and D, so we have 2 here, 2 here, 3 is here, 3 is here, 4 is here, 4 is here, 5 is here, 5 is here, 6 is here, 6 is not here. We have 7 here, 7 here. So we have 7. 8 is here, 8 is here. We have 8. And that is all. Now the n of A union C intersection B prime means the number of elements in this set. So we count 1, 2, 3, 4, 5. So we have it as 5. There are 5 elements in A union C intersecting with B prime. So that is the end of the solution to this problem 1. We go to problem 2. In problem 2, in a class of 45 students, 18 offer economics, 22 offer physics, and 6 offer chemistry only. 7 offer chemistry and economics, 8 offer chemistry and physics, 4 offer economics and physics only, while 8 offer none of the 3 subjects. A. Represent the information on a Venn diagram. B. How many students offer 1. The 3 subjects. 2. Economics only. So we'll start the solution from A, that's representing the information on a Venn diagram. Before we go, we'll let U be all the students, C, E, and P be students offering chemistry, economics, and physics respectively, so that the rectangle represents the universal set, and our circle is for this chemistry, the other circle for economics, and the third circle for physics. So it is our tradition to start from the student offering the 3 subjects, 2 subjects, then the 1 subject. So the set notation is C intersection E intersection P, where the number of students will be represented as X, and it is in this region. Then the student offering chemistry and economics only, that's N of C intersection E intersection P prime. So P is not there. So we are going to have the number of students offering chemistry and economics. Chemistry and economics, they are 7. Since they didn't put only, if they had put 7 offer chemistry and economics only, we just put it directly here. Since they didn't put only, we are going to remove the number of students offering the 3 subjects, so that we now have it as 7 minus X, and the region is this. Then we go for student offering chemistry and physics. So that is N of C intersection E prime intersection P. That's number of students offering chemistry and physics only. So we go there and know the number of students offering chemistry and physics. Offering chemistry and physics. Yeah, there's 8 students offer chemistry and physics. And since there is no only, we are going to remove those offering the 3 subjects from 8, so that we now have it at 8 minus X, and this is the region. And now the number of students offering economics and physics only, that's going to be N of C prime intersection E intersection P. C prime, so C is not part of this. It is only E and P only. So first offer economics and physics only. Since it is only, so we don't need to subtract those students offering the 3 subjects. So we just have it as 4, and the region is here. This is the region. Now we go further to get the number of students offering 1 subject. That's chemistry only, economics only, and physics only. Now to do that, That's going to be n of C intersection E prime and P prime. That's number of students offering chemistry only, and 6 offer chemistry only. Oh, that's 6. So we have it as 6. It is the region here. Then we go for number of students offering economics only. That's going to give us C prime intersection E intersection P prime. No C, no P. So we go ahead to know those offering economics, or if we are giving economics only. No. 18 offer economics. For your information, the whole of this circle constitutes the 18 students that offer economics. That is 7 minus x, 8, and those offering only. So to get those offering only, now we can just say 18 minus all this, so that we now have it as 18 minus 7 minus x minus 4 will give us those offering economics only, and that will give us 7. To give us 7, because it's going to be minus 7 plus x minus x. Minus x plus x will give us 0. So 18 minus 7 is 11. 11 minus 4 gives 7. So this is 7. So it comes to this region. And those offering physics only, that's n of C prime intersection E intersection P. So again, it is going to be 22 minus 8 minus x minus 4, because the whole of this circle is 22. This is 22 minus 8 plus x minus x. Plus x minus x is gone. 22 minus 8 minus 4 gives 10. This is the region for that. So we now go ahead to calculate those that are offering neither of the 3 subjects. So that is C prime intersection E prime intersection P prime. So here, while 8 offer none of the 3 subjects, so they are 8, and it is going to be found in the region outside the 3 circles, so it can be placed anywhere outside the 3 circles. So with this, we have done justice to problem A. We now go ahead to problem B. For problem B1, to calculate the number of students offering the 3 subjects, it means we are to find the value of x, and be informed that we have 8 groups of students here. Those offering the 3 subjects, those offering chemistry and physics only, those offering chemistry and economics only, those offering physics and economics only, those offering chemistry only, physics only, and economics only, including those that are offering none of the 3 subjects. So if we add all of them, it gives the number of students in the class. So that we now have it as x plus 7 minus x plus 8 minus x plus 4 plus 6 plus 7 plus 10 plus 8 is equal to 45. So this x minus x gives 0. We are left with negative x here. This is negative x. 7 plus 8 gives 15. 25. We have plus 50 is equal to 45. So we solve this equation. We have x is equal to 5. Therefore, 5 students offer the 3 subjects. Now we go to the number of students offering economics only. The number of students offering economics only has already been calculated. So we have it in this Venn diagram as 7. Therefore, 7 students offer economics only. we have done justice to problem 2. So we go to problem 3. In problem 3, in a survey involving 42 sportsmen, 18 play cricket, 23 play soccer, and 22 play tennis. 9 play cricket and soccer, 8 play cricket and tennis, while 7 play soccer and tennis. Everyone plays at least one of the 3 games. Oh, that means there's nobody outside the 3 circles. All of them will be inside the 3 circles. Okay, that's to say cricket prime intersection soccer prime intersection tennis prime is an empty set, and their number is 0. So we go ahead to start the solution of the problem from A by representing the information on the Venn diagram. So we are going to use E to represent all the sportsmen, C to represent cricket players, S to represent soccer players, and T to represent tennis. So, and our rectangle is the universal set. Our C is the circle, the second circle is S, and the third circle is tennis. We start with the sportsmen playing the 3 games. We are not given, so we represent that one as X. That is C intersection S intersection T is equal to X, which represents the number of sportsmen playing the 3 games. Then we put the region for this is. Then the next is those playing cricket and soccer only, which is this region. So that is N of C intersection S intersection T prime will be equal to 9 play cricket and soccer. Since there's no only, so we remove X, so that will be 9 minus X, 9 minus X, and this is the region. Those playing cricket and tennis, 8 play cricket and tennis. That's N of C intersection S prime intersection T. That's going to give us 8. Since there is no only, still 8 minus X, and this is the region. And we go for soccer and tennis only. That's N of C prime intersection S intersection T. So with that, we are going to have it as 7 plays soccer and tennis, and since there's no only, it's going to be 7 minus X. Then we place it on in this region. Now we go for those playing cricket, soccer and tennis only. So here for cricket only, 18 play cricket, so that's going to give us N of C intersection S prime intersection T prime, which is going to be 18 minus every other thing within this circle to give us this only, minus X, minus 8 minus X, and minus 9 minus X. If you simplify this, we have a 1 plus X. We have 1 plus X, and it goes to this region. Now for soccer only, that's N of C prime intersection S intersection T prime. We need to know those playing soccer. That's 23. So it's going to be 23 minus X minus 9 minus X, then minus 7 minus X. If you simplify this correctly, you have a 7 plus X, and it comes to this region. Those playing tennis only, that is N of C prime intersection S prime intersection T. How many of them playing tennis? 22. So that's going to give us 22 minus X minus 8 minus x minus 7 minus x. So if you simplify correctly, we have 5 plus x, which comes to this region, 5 plus x. Since everyone plays at least one of the 3 games, so outside this 3 circle is an empty set. We have succeeded in representing the information on a Venn diagram. So we go to problem B. For problem B, the number of sportsmen playing the 3 games. To do that, we have to find the value of x, and we should know that by the time we add all these, they make up the 42 sportsmen that are involved in the survey. So that's going to give us x plus 9 minus x plus 8 minus x plus 7 minus x plus 1 plus x plus 7 plus x plus 5 plus x is equal to 42. So this cancel this cancel this cancel this, so I'll be left with 37 plus x is equal to 42. If we add up these numbers, 37 plus x is equal to 42, x is equal to 5. So 5 sportsmen play all the 3 games. And we go to the second part of the problem. Those playing exactly 2 games are cricket and soccer only. That's this region, soccer and tennis only, cricket and tennis only. So those playing exactly 2 games are 9 minus x plus 7 minus x plus 8 minus x. 9 plus 7 plus 8 gives 24 minus 3x. That's 24 minus 15, which gives 9. So there are 9 of them playing exactly 2 games. This is the end of the solution to this problem. This is the end of this tutorial. I hope you enjoyed this lesson. Remember to subscribe to our YouTube channel, Unidab Resources. Like and share this video. Until we come your way again, goodbye.